this session. Today, today we will work on this Arista Vxlan EVPN Fabric Lab. I will try to demonstrate the two types of IRB models we have on this platform. First of all, we need to understand what exactly is IRB. IRB stands for Integrated Routing and Bridging. So IRB was drafted by IETF Internet Engineering Task Force to provide a more optimal forwarding model and to avoid traffic uh, tromboning. So what exactly is traffic tromboning? Is a term that colorfully describes inter-VLAN traffic flows in a network with stretched L2 domains. So if you see on this on the topology which is showing on the screen, we have some hosts connected to AS200 and some hosts are connected to 300. So in data center or multi-tenant data center, we usually have this type of topology. So we have L2 stretch VLAN. So that traffic is known as that that terminology is explaining traffic tromboning. So IRB proposes integrated routing and bridging functionality directly on the onto the VTAP. So therefore, allowing the routing operation to occur as close to the end host as possible. So if we try to understand the traditional data center design, the inter subnet forwarding is provided by usually centralized router. So with the traffic traverses across a network to a centralized routing node and come back again to its final destination. So if that type of environment or that type of traffic flows we have in large multi-tenant data center, so then that can lead to inefficient use of bandwidth and suboptimal forwarding. So this is the reason IRB was created. So uh, I, IETF proposes two forwarding models for IRB functionality, uh, which are termed as asymmetric IRB and symmetric IRB. So we will work on these two models today. So I will try to demonstrate the configuration and the packet level information that what exactly is the difference between these two models. So first of all, we will work on asymmetric IRB model. So in asymmetric IRB model, the inter-subnet routing functionality is performed by the ingress VTAP. So VTAP uh, in in this topology we have this leaf and this leaf, and these two are spine switches. So these leaf switches which are connected to the end host directly, they are known as VTAP. So the routing functionality is performed by this ingress VTAP with a packet after the routing action after the routing action being performed, then Vxlan, which we configured on this VTAP, bridged that packet to the final destination or the destination VTAP, just in case if we are having some host connected on this VLAN 10, try to connect this host on the VLAN 10, it will need to go to this VTAP. So this VTAP will be a destination VTAP. So this is ingress VTAM and this is the egress VTAP. Whoever gets a packet. Okay. So the egress VTAP only then needs to remove the VXLAN header and forward the packet onto the local layer 2 domain based on the VNI2 VLAN mapping. So so this is the way that how traffic moves in one way, but in the return path, the routing functionality is reversed with the destination VTAP. Uh, this destination VTAP now perform the ingress routing and VXLAN bridging. So the routing will be done on the local VTAP. If a traffic is moving from this way to this way, the routing will be done on this leaf. And if the traffic is coming back, then routing will be done on this VTAP. And after the routing, the bridging will be done. So this is a reason this is known as the asymmetric IRB. Another thing is Anycast gateway. Just need to mention that as well. So to provide inter subnet routing on all the VTAPs for all the subnets, and any cast IP address is utilized for each subnet and configured on each VLAN. So just in this case, we have VLAN 10 and VLAN 20, and we will be configuring the Anycast gateway on this VTAP, uh, and same thing we will do on this part. VLAN 20 we will create here, and VLAN 20 SVI, VLAN 10 SVI we will create on this VTAP. So Anycast IP act as a default gateway for the host. So therefore, regardless of where the host reside, the directly attached VTAP can act as host default gateway. So uh, so the host MAC and the MAC to IP bindings are learned by VTAP based on the combination of various things like local map learning, ARP snooping, or type 2 advertisement. So this is a very important thing, type 2 route advertisement, uh, which usually comes from the remote VTAP. We will see that in the packet capture, that uh, how it helps in getting information about the remote host. So just in case we have this topology, uh, if if the traffic need to flow between this from this VLAN 10 host, this is host A VLAN 10, and it wants to communicate with the VLAN 20 host, which is host B, which resides on connected to this VTAP. So so how the traffic will move? The traffic first, this host will try to ping VLAN 10 this host. It will first go to this VTAP, and what this VTAP will do, it will first locally routes a packet into the VLAN 20 subnet, and the VNI which is mapped to that particular VLAN. So just in case in this topology or in this lab, we will be using VNI 10020 for this particular VLAN 20. So the routing will be done on this VTAP from uh, to VNI 10020. After the routing is done, we will use the Vxlan, means Vxlan bridges a frame, inserting the VNI 10020, which is for VLAN 20, into the Vxlan header, and it will forward that uh, to a destination host. That will then, this Vxlan packet uh, will go to this spine, and then it will go to any of this of these VTAPs. So so when the receiving VTAP receives this packet, it will do whatever the whichever the VTAP received that packet, that VTAP will do the decapsulation and then forward that particular packet to the end host. So this is the overview that how VXLAN routing and bridging is performed in this platform. So just need to understand basically that for asymmetric model to operate, you know, to operate the sending VTAP, you know, needs to have the information of all the tenant hosts. Means this VTAP need to have the information about these hosts, and this VTAP need to have the information of the both VTAPs need to have the information of these two hosts. So this means that VTAPs need to be the member of all tenant subnet of the VNI, or they should have associated SVI with any cast IP address for all the subnets. So this requires all the VTAP participating in the routing functionality should have all the SVI. Means for this VTAP, if we have these two VLAN, then we must have these two SVI created on this VTAP. All right, let's move into the lab quickly. Let's see what we have achieved here till now. So at the moment, I have already done the basic configuration. So the basic configuration, if we see this topology, these are spine switches, leaf switches. The underlay configuration is already been done. In underlay configuration, we have done the BGP, or we are using only one protocol BGP here, and eBGP specifically we are using. So it depends on case to case or vendor to vendor, but Arista recommends to use eBGP, but in spine and the leaf. and some other vendor use IBGP. They have their own, you know, case to case, that how they are implementing this platform. So underlays configured. We have the BGP eBGP session established between VTAP to spine. We can see the overlay EVPN BGP session that is also established. So just to save some time, I have already done the configuration on these two spines and these two VTAP. I will demonstrate the configuration on this VTAP only. So let's see what we have. Uh, let's check the BGP session. So BGP session, this is the underlay BGP, which is up and which is showing established with these two spines. This is leaf 2A, and let's see if we have, okay. The underlays BGP session is up. We are seeing three BGP pairing. So the one pairing which is showing here 192, this is the MLAC pairing. So uh, these two VTAPs are in MLAC pair. So we have BGP session running between these two. That is IPGP session. Okay, so let's start. Let me show the BGP configuration we have. So the BGP configuration, we have the route map. In route map, we are using a prefix list for the loopback 0 and loopback 1. So this is a very critical part, that loopback 1 and loopback 0 they should have the each VTAP should be able to reach the loopbacks of other VTAPs. This is a very first thing, because that is the reason we have to advertise these loopbacks in the underlay so that they can have the reachability in the BGP configuration. We must be using one more thing. Just need to mention here that address family. So in this implementation, we are using single protocol, which is BGP, and we are using the address family, different address family. So both address family, one is IPv4 address family and the EVPN address family. So EVPN address family is used for the overlay. IPv4 address family is used for the underlay. And there is one more address family, which is VPN v4, just in case if in the large data center, or usually we have that type of implementation, we should be having a border gateway switches, or VTAPs, which are connected to the other DC connected connection. So those VTAPs should also be having VPN v4 address family. So basically three address family we are covering in this implementation. All right, so let's start with the configuration. The very first thing is Vxlan interface. So whenever we are creating a VTAP, we need to create a Vxlan interface. I think we already having that Vxlan interface here. So this is already configured. We can see the source interface is loopback 1. So loopback 1, so in the topology, spine switches are not having loopback 1, they are only having the loopback 0, but the leaf switches which are VTAP, they are having the both in loopback 0 and loopback 1. So loopback 1 is for the VTAP, means for the tunnel, and the VXLAN tunnel that we created. Loopback 1 is used for that source and destination. We will see that in the packet capture. Okay, so we have done the VXLAN to VNI mapping. So VNI is globally significant, means globally significant in the fabric, and VLAN is locally significant. We must need to map VLAN to a VNI map. This is L to VNI. Okay, let's see. Hmm. Now the next thing is we need to create the VLAN here. If we have the show VLAN, okay. We are not having the VLAN. Let's first create the VLAN quickly. VLAN name 10, VLAN 20, name 20. All right. Now we need to create the SVI VLAN 10 here. So let's add this VLAN to VRFA and then IP address virtual. So this is virtual IP address, which is which I explained earlier, that any cast gateway. So we will be putting the same virtual IP address for this SVI on all the VTAPs. So VLAN 10 interface, VLAN 10 SVI will be having the same IP address. So if we, this will be VLAN 10. If we check on VLAN 10 on the other leaf switch, it is sure. It is 200.200.200.1. So we need to put the same IP address here. ERFA, let's create the same thing for VLAN 20. If we check what SVI we have on other, this is 100.100.100.1 address. Hmm. Now when we check this Vxlan interface, it's showing not connected. Why? We can see the mapping is there, VLAN to VNI mapping is there, but the replication flood mode is still need to be initialized. So and also one more thing, the listening is a 4789. This is a Vxlan destination port. Now go to let's go to the routing PGP configuration. Show active. Hmm. So we will do the MAC VRF configuration. This is we are using what I would say, we will be using MAC VRF, and here when we put the VLAN 10 here, it's showing that we are in the MAC VRF configuration. Here we will need to add two things. One is route distinguisher and the route target. So route distinguisher is used to make the route unique in the fabric. So this is the reason it will just in case if we have multi-NAND environment and we have other VRF, say VRFB, so we can use the same subnet for that VRF. So just to make the unique, we need to make the route distinction values. All right, so let's then put the route distinction configuration route. Here I'm using the loopback of this switch, then I will put the VNI, the L2 VNI for this particular MAC VRF. Route target. Route target is the route target it should be the same for this MAC VRF for this VLAN 10. Means it should be the same for on other VTAPs as well. So let's put this. And last thing, redistribute. Let's do the same thing for VLAN 20. Target both redistribute. Yeah. Okay. Now let's see if we are having let me just find one switch. Show BGP VPN time. Okay, so you can see that we have type 3 routes which are provided by leaf 1. This is loopback of leaf 1, and this is for the VNI 10010, and this is a loopback 1 IP address. So it's advertising the type 3 route for this VNI and route distinction. Okay, now let's start For the now we will do try to make the connection between the different hosts, and then we will see the packets that what packet will be initiated from this leaf, as well as we see the encapsulation and a decapsulation on that on the other VTAP. So for that, let's I need to shut down this interface which is connected to spine one, then I will do the packet capture on Ethernet one. So let me quickly shut down this Ethernet tool. Okay, shut down. Now let me start the packet capture on Ethernet one. Okay. Mm, at the moment, we are not seeing any much traffic, but yes, certainly it will start. So these are the basic packets, keep alive message between the BGP sources 172.16.10.1, 10.3. These are the underlay IP address we can keep alive, and also we can see the TCP session, which is an essential for BGP, and we can see those packets. So this is normal. We are not seeing at the moment anything related to the Vxlan. All right. So let's start these hosts. First of all, let's start VLAN 10 on here and VLAN 20 here. Open this. Just trying to make some space here. All right, so let's check the IP address. So IP address is 100.100.100.30. This is correct here. This particular source, and the IP address here is 200.200.220. So this one. Okay. Do we have anything here? Okay, this is a get users up. This is fine. So because we are having uh, this host in the network, so it will start sending the get issues up in the network. Keep like keep. Okay, I'm just want to see if we are having update message. Okay, here it is. PGP updates message. Hmm. This is PGP. We have the path attributes. So this is a path attribute. If you can see, these are the uh, mandatory attributes or region is path. Then we have this one, MP reach NLRI. This is important. Then we can see here. This is sending. Okay. Next, this is going network layer reachability information. MAC route advertisement. Yes. Now it's sending this one. MAC 6807. Now see who is 6807. 6807, this one. So 6807 is the MAC address of this host B in VLAN 10 here. VLAN 20. This one. This one VLAN 20. Okay. So now we are seeing the BGP update message in which we are seeing the MAC route advertisement for this particular MAC. Yeah, the MAC addresses, and we are also having this information attached with this. The next hop, this one, and we must be having the VNI. Yes, VNI is also included here, 10020. This is for this host 6807. This one. Let's check for other one 6807. Yes. So this is for oops, this is for this host VLAN, this host A on VLAN 10. The same thing we can see. Uh, VNI 10020. Why we are having this VNI here? Let me check it. 6807. Oh, okay. This one same. Let me check this one. 6807. 6807. Let's let, let's wait for some more bit message. This Vxlan is up. It's showing dynamic VLAN mapping is EVPN. It's what this one. Static MAC address is this. So need to be sure that the application of flood mode is EVPN. So we are using the EVPN method to advertise all the routes as well as the VTAP address. Let's check one more thing here. Show it is on we are on the other VTAP. Show Vxlan flood VTAP. Yes, we can see here. This is the this out this command is providing us information about that for this VLAN to which VTab we need to flood send the traffic. So for this particular VLAN, so whenever we have any packet, we also need to advertise those to this particular VTab. Okay, this is clear now. Message. Uh, 6809. Okay, this one is for 6809. Okay, all right. So at the moment, we can see one thing that on both side on the both side, whenever we have these hosts connected, these VTAPs start sending the type 2 routes and start informing the other VTAPs. Say, see, I'm having this particular host in this VNI or in this VLAN. So this is information about that particular host. This is the MAC address. This is the VNI, and etc. It's providing all the information. So both the on the both end they are having the information about the host connected to the remote VTAPs. Okay. Now let's see if we are able to ping from this host to this. Let's see. Okay, this is successful. Fantastic. So here we are able to ping from this host, which is in VLAN 10, to the host in VLAN 20. So traffic is going from this VTAP. This VTAP will do the Vxlan encapsulation, then it will go to this VTAP. This VTAP will do the decapsulation for the traffic. So we can see this whole scenario in the packet capture. This is the pie chart we can see here. These are the packets which we are sending, ping response. All right. So the first packet, this is coming from this source. This is our end host 100.30 and this is 200.20. These are our hand host. This is the ping echo, or I would say the check this one, the request one, because this is request one we need to check. Request one is this one. Okay, sorry. Here we can see from 200.20 to 100.30, 100.30 from 200.20. We are having this packet. This is the internal IP packet here. This is the Ethernet header here. You can see in header, we can see the destination is 6807. 6807 is the MAC address of the end host. This one, but the source MAC address. I believe this MAC address belongs to the VTAP which is doing the encapsulation. And in the IP header we can see the source and destination. This is fine. We can see these are the IP address for the end host. But after that, we can see we have the Vxlan encapsulation, Vxlan header. In Vxlan header, we can see the VNI mapped, which is 10020. So we are following the asymmetric model. In asymmetric model, the traffic, uh, the packet is being routed in the destination VNI, which is VNI 10020, and the packet is encapsulated, with the VXLAN header, and the VNI mentioned is 10020. And when we open these flags, it's not having much information. Okay, then we have the outer header here, and we can see the destination is 4789. So this should be uh, this should be identical for all the traffic in the VXLAN, encapsulation. All right, and the outer this IP, this header you can see, 20.1 to 20.2. These are the VTAPs. So So in the loopback one, which we have configured, those are for the source and destination for the VTAP VXLAN tunnel. So this is the reason we can see these two IP address showing here, because we are doing the VXLAN tunnel, the source and IP address, source and destination IP address are used here. And the last one is the Ethernet header, so it will be changing. Uh, I would say node to node means. So every time it go to next segment, this will get changed. So this is the one, one side. So when the packet comes back, if you see the reply, it will the same thing, but the only change you can see here is the VNI. Now the traffic which is coming back, we can see that VNI is 10010, which is for VNI or VLAN 10. Rest of the things we can see the source and destination would be the same. It will just show opposite, same thing we can see here. So the idea is, in asymmetric model, the local VTAP will do the routing, and after the VXLAN encapsulation, means then it will do the VXLAN encapsulation and then do the bridging. And on the remote VTAP, uh, that will also perform the same way. Mean it that VTAP will do the routing and then do the bridging. So this is the way that how this asymmetric IRP model functions. So uh, just need to be, there are various things that we need to keep in mind, that whenever we are following this type of model, we need to have all the SVI to be created on the VTAP. So it will just put some scaling issue, because it's not easy to, sometimes it's not feasible to get all the SVI to be created on the VTAP. All right, so this covers our asymmetric model. Let's move to the symmetric model here. Let me close this session. Just a moment. Okay, so let's start with second IRB model, which is symmetric IRB model. So in symmetric IRB model, uh, I would say we we will not see much difference. The only thing is, we will have uh, the layer 3 VNI. So earlier we were using the L2 VNI in asymmetric model, and each L2 VNI was mapped to one VLAN. So each VLAN is dedicated for one particular L2 VNI. But in symmetric model, we will be having a single VNI, which is known as L3 VNI, which is mapped to one VRF. So the traffic that we will be moving between VLANs or inter VLAN, or the same VLAN, the traffic will move via that particular layer 3 VNI. So this is a reason why we are calling this a symmetric, because when we will see the packet capture, so the request and the reply packet both will be using the same VNI. So the good point for this symmetric model is that it is not mandatory to have all the SVI to be created on the local host. Means if one host is having you know one SVI, it's not mandatory to have same numbers of SVI to be created on this VTAP as compared to other VTAPs. Okay, so let's start the configuration. So uh, one more thing, let me show you something before moving to symmetric model. If we see in asymmetric mode, we were still running asymmetric. Let's show you something. Show BGP EVPN route type MAC. Alright, so it is not showing. Let me ping it again. So this is the command where we can see type 2 route. It's getting advertised. So as soon as we start pinging, so we can see these type 2 route type 2 routes advertised by were done by BGP here. So it will be advertised to all the VTAPs. So basically we need to be sure. So this is the important thing when we're doing troubleshooting. We need to see if the remote VTAP is running type 2 route for any particular host or not. Okay, let's move into the submitting model. So here we will be using VNI, layer 3 VNI, and that will be mapped to VRF here. So we are already having the VRF configure show VRF here. So we are having this VRF. Now show active Vxlan VRF VNI. So we have mapped with this VNI. When we check Vxlan show interface Vxlan 1, we can see this one dynamic VLAN to VNI mapping for EVPN is this one 15001. Static VRF to VNI mapping is with VRFA. We can see this is mapped to 15001. All right, this is completed. Now let's go into the PGP configuration. Router PGP 200 VRF VRFA. So one more thing is that this need to be identical. If we check the other VTAB show on section BGP, we can see this thing here because root target should be same, and then the root distinguished value it should be as per the loopback. Okay, so we have this loopback 101 here, root target uh, EVP export EVPN 1:1 import and redistribute connected. Here we are using redistribute connected. When we were using Mac VRF, we were using redistribute learn. Okay. Let's check on the packet capture if we are getting anything there. Okay. All right. So we have this. Okay. Let's try if we are able to ping the end host. We are now. Let's see here. Where is the request packet? The first request packet is here. And let's go into the Vxlan header, and we can see the VNI is 15001, which is a layer 3 VNI. And if we see in the reply packet, we can see the same VNI, which is 15001. So this is symmetric model. Means we are not seeing a different VNI. This is the layer 3 VNI here. Another thing is we need to check here, this one. This one here, in the asymmetric model, we were seeing the destination as the destination MAC address of the host, but here it's not like that. We are seeing these MAC address. I believe they belongs to VTAP. Yes, they belongs to VTAP. So here we are not putting the MAC address of host here. The rest of the thing, I believe the same destination port is this is fine, and the IP. These are the tunnel source and destination IP address. So here we are able to make the communication between different VLAN, VLAN 10 to VLAN 20. Okay, there is some more point here. Let's check that. Show VLAN dynamic. Yes, you can see here EVPN. Yes, 4093 is a dynamic VLAN. Uh, you know, this is created for IPv4 FTVN mapping. So both should both if we are having MLK pair, then they should be having this same one. Okay. I think this covers our one more thing. Show IPGP's summary. Show IPGP neighbor. Uh, Neighbor capabilities. Yes, this is neighbor capabilities, and I was just checking something here. Uh, L2 VPN. Yes. Okay, this is L3 VPN. All right, so I think this completes our quick video. This was all about to demonstrate the two IRP models. I hope you have liked this video. Thank you very much for your time. Have a good day.